Hello, and welcome to Tech to Tech presented by KaiZeN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Scott Cain.
Thanks, William. And thank you to everyone else for taking a few minutes out of your time to learn a little bit more on this edition of Kaizen's Tech to Tech. Today, we will be doing a case study on solubility testing for advanced packaging. And really, what that is the creation of a data-based matrix to maximize application parameters. This is co-done by myself and my associate Jason Chan. I'll be presenting, but Jason and I worked on the information together. So, what was the opportunity or the overview of the project? And what we had was a large advanced packaging customer. They had various sizes of flip chips, and due to increase in production, they wanted to move to a new style of machine. They weren't sure if the chemistry was going to be able to work in the new style of machines when they went to an inline machine. And they wanted to check the solubility of the existing chemistry versus Kaizen at various concentrations and against various states of fluxes and reflow. And they had sent us 5 fluxes, but they were anonymous. They didn't tell us what the fluxes were, so they were just labeled A through E. So as you can hear, there were a couple different variables involved in the testing. Kaizen chemistry versus what we'll refer to as chemistry X. The concentration of the chemistry, they wanted 5%, 10%, and 50%. The flux types, there was A, B, C, D, and E. Reflow of fresh and reflowed fluxes, the percentages at 3, 5, and 10%. So a lot of different stuff we had the customer was looking for. So we put together a matrix such as this. And we actually had 3 of these due to the fact that the concentration was at 5%, 10%, and 50%, as you see on the left. So you can see the different flux types, the chemistry, the competitor, and the Micronox 2708, and the flux loading at 3, 5, and 10%. And the numbers that are there right now are just the math is how much 3% of 20 milliliters. So the process that we went through, each flux was weighed per the testing matrix using a 2 decimal weighing balance. And the reflow is simulated using a hot plate of either 250 degrees C or 300 degrees C, and the material reaching a minimum of 227 C for 90 seconds. Now, you may be asking why there's 2 different temperatures there being used. As you can see on the bottom, for the 5%, we were able to use metal pans. The problem was the competitor's material ate away at the metal pans, and so for the 10 and 50%, we had to use a porcelain dish. Due to the porcelain dish and the heat transfer, the temperatures that we ran the hot plate at were a little bit different. So that's why it was 250 on one and 300 on the other. That was just what was needed to get the material up to the 227 based off of what the holding canister was. And to continue that, we took 500 milliliters of chemistry, is prepared on the hot plate uh, based on the requirements of the hot plate that we just discussed. The chemistry is brought to and maintained at 70 degrees C using a hot plate stir and stir bar. We set that to the number 2 speed, and 20 milliliters of heated and correctly mixed chemistry solution is transferred using a measuring cylinder. So as you can see there, we're utilizing that to bring that material over. Then the hot plates are set for 80 to 100, 80 or 100 C, again, based off of what we discussed with the material differences, to ensure maintenance of 70 degrees C for chemistry during testing. Then 20 milliliters is transferred to the sampling apparatus for the flux, stir bar is added, set it to 2, and the clock begins. So at that point, what we start doing is visually observing the solubility. And when the flux is fully solubilized, we take a picture and we time it out at 10-second increments. So if it solubilizes fully at 37 seconds, then we're going to call that 40 seconds. We're taking pictures all the way through the process to make sure that we have data that backs up what the times are that we're recording for all the chemistries, all the concentrations, all the reflows, et cetera, et cetera. So then we put that into a table. So we can see here that the 5% chemistry concentration for the different fluxes have a variability on what the time was. Keep in mind, each of these are in seconds. So the E-type flux, neither us or the competitor was able to solubilize that. Whereas the C-type, we look across as the flux loading goes, the time goes up, the Kaizen is a minimal amount better on each time. So 110 seconds to 100 seconds, 130 to 110, 180 to 150, etc. So let's see what happens once we got to a 10%. So we get to 10%, the E still doesn't work. It's non-solubilized. You can see that some of the Ds that we weren't able to solubilize at 5% concentration, at 10% we're able to get. But let's take that C line again and see that now with double the concentration, the timing that it takes for these to solubilize is much less. If we look back, it went from 110 over 100 to 35 to 25 seconds. So this is really good information for the customer. It lets them know, okay, we can increase the concentration, but our throughput can be much more. And then they have the ability to determine what's the value of that if we want to increase the concentration, which of course there's a cost to, but how much is it worth to be able to get more parts out? Then let's look at what happens with 50% concentration. You can see that E is still not soluble in that. And then let's go back to C. We keep using that as an example, and we can see that the numbers there are pretty much the same. 40 over 35 on 50%, and at 10%, it's 35 over 25. If we go back to 50, you can see like there's no value in going that high with the chemistry concentration. These numbers are actually, as a whole, a little bit worse than the numbers that we see at 10%. So this provides the customer a lot of really good information to make a determination based off of how much flux, which flux they're using, how loaded it is, what the chemistry concentration is, et cetera, to figure out what's going to be best for their throughput. And as we said, the chemistry actually attacks aluminum, and that's really important because they did not know this going into it, and there's some stuff in the applications that made affect. And so what we did is we took all the information and charted it out for the customer. You can see that this has both the fresh and the reflow based off of the style of flux on the side, the A, B, C, D, and E, and what loading that is. So now we have this information, the customer can look at it. They can see that the Kaizen chemistry won 58% of the time, or 58 out of the 90 were Kaizen. There were 8 or 9 of those that the chemistry X results were better. Of course, we saw all those E's did not work at all, so neither of those were solubilized, and the rest of them, the chemistry X and the Kaizen material were the same. So the conclusion is the Kaizen material provided better cleaning results and provided the customer with extensive data. And really what that helped them do is further quantify exploration into changing the chemistry and the machine, give them the information to move forward and decide what they want to do. Additionally, the higher concentrations promote better solubility to a point. Right? We saw that we don't want to go to that 50%. That's not really, there's no value in that. But adding 5% of the concentration on that, it definitely saves them some time and some money. And especially for this fine pitch and low standoff applications. Full material transparency can lead to better testing. So really what we're saying there is, you know, they provided those as chemistry A, chemistry C, etc. When we know all the information about what those materials are, then we can dig into that and figure out exactly which chemistry is going to be the right solution for that. And without knowing that information, we're kind of shooting in the dark a little bit. And so the more information we know about what we're trying to clean or what we're trying to solubilize, that always helps us out in the long run. And they also found out that, as we talked about, the competitive chemistry could not be tested in the aluminum test cups, which would cause problems in the copper pillar flip chip applications. And they didn't know that going forward, coming into this application. And so knowing that information now helps them make a determination on what they're doing in their applications. So just a couple things, we're here to help the chemistry suppliers, the machine people, the flux manufacturers. All of us are experts in the cleaning process. So we're happy to help with anything you need. Think about all the time and effort it took to put this test together, all the materials that were necessary, all the lab stuff. We can be an extension of your engineering department. Yeah, this is something somebody could do in the field, but it's a lot of work. And we're happy to be an extension of your engineering to just assist on projects like this. And you're always welcome to come to our lab and see it being done. And by the way, hey, we love talking about this stuff. So we're always available to help your teams. Just a few frequently asked questions that we've gotten on this. The first being, why were the fresh and the reflow fluxes both tested during the analysis? Really the reflow flux was the most important. The customer wanted to see what the fresh was just for a comparison's sake. And so we were happy to provide that because that's what they requested. But really the core data for this project was going to be that reflow flux. Question two, is it normal for a customer to provide the material anonymously? And what effect does this have on the results? It's pretty rare that they do that, but if they want to do that, we're happy to provide the results that way. But as I mentioned earlier, it's a little bit easier if we know what the material is. We know how some of our chemistries react with different materials, and knowing all that information definitely helps to make sure that we are suggesting the right solution based off of the information we're provided. And finally, are these tests something that I can run in the field? They are, absolutely. And our team can help you set that up and run that. For a project of this amount of variables, it's definitely something that maybe you want to have somebody else do it so you're not wasting all your capital, be that your personnel and a financial side. But this is something our team can help you set up in the field if you're wanting to run one-offs on questions like this. So thank you so much, and I'm going to send it back to William.
Thanks, Scott, and thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local KaiZen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.